Hi everyone. In the last class we have discussed the deformation of body due to a force acting on it, and we have already calculated the derived equation, or we have studied the equation delta L is equal to PL by AE. So we have studied in the last class, and we have done few problems in connection with that. It's our first problem, delta L is equal to PL by AE. Okay. Now we go to our second problem. A hollow cylinder of 2 meter long. Here the length is given as 2 meter. Has an outside diameter of 50 mm. Outer dia and inner dia is given. So we can calculate the area of cross section. If the cylinder is carrying a load of 25 kilonewton, find the stress. The P is given as 25 kilonewton. Find the stress. We have to calculate the value of sigma, or P divided by A. Also find the deformation delta L. We have to calculate if the values of modulus of velocity for the cylinder material is 100 gigapascal. So we are asked to calculate the value of stress. So in the question they have given the load and they have given the diameter. So we can calculate the area from the given value. So here is the given value, length is given, outside diameter, inside diameter is given, load is given, modulus of velocity is given. So first we will calculate the value of stress. For calculating the value of stress, we need load and area. For area, they have given the inner and outer diameter. We can calculate the area as 1257 millimeters square. And from that, we can calculate the value of stress as 19.9 megapascal. Then they ask to calculate the deformation delta L, which is given by PL by AE. So we can calculate the value of P is given, L is given, A is we have calculated, E is also given. Again, the value of E is given as gigapascal. So Pascal is equal to Newton per meter square, and we can convert Pascal into Newton per millimeter square. 1 megapascal equal to 1 Newton per millimeter square. Normally we will be doing the calculation in terms of millimeter. So we will convert the 100 gigapascal into Newton per millimeter square. So we can write 100 into 10 raised to 3 into 10 raised to 6 Pascal. 10 raised to 6 Pascal equal to megapascal. So megapascal can be replaced by Newton per millimeter square. That's why here they have written 100 into 10 raised to 3. Now its unit is Newton per millimeter square. And at last the elongation is obtained in terms of millimeter. Okay. So here is one more question. A load of 5 kilonewton is to be raised with the help of a steel wire. Find the minimum diameter of the steel wire. The stress should not exceed 100 megapascal. So they have given the load, they have given the stress, we have to calculate the diameter of the wire. So take it as a homework. Here is our next question. In an experiment, a steel specimen of 13 mm diameter was found to be elongate to 0.2 mm in a 200 mm gauge length. So in each experiment, steel specimen diameter is given. So from the diameter, we can calculate the value of area of cross section. They have given the diameter. We can calculate the value of area of cross section. Found to elongate by 0.2 mm. So delta L is equal to 0.2 mm in a 200 mm gauge length. So L is given as 200 mm gauge length. It is subject to a tensile force is given as 26.8 kilonewton. If the specimen is tested with elastic range, find the value of Young's modulus. We have to calculate the value of E for the steel specimen. So we got the value delta L is equal to PL by AE, in which they have given delta L is given 0.2, P is given 26.8, L is given 200 mm, and A we can calculate from the diameter. So we have the only one unknown is value of E. So we can calculate the value of E using the equation. So they have calculated the area first. Now they have written the equation delta L is equal to PL by AE, and they have substituted the value of P, L and A. The only unknown is E. The value of E is calculated as E is equal to 201.9 gigapascal. Okay. Normally we will be obtaining in terms of Newton per millimeter square. 1 Newton per millimeter square equal to 1 megapascal. 1 kilonewton per millimeter square is equal to 1 gigapascal. So we will be writing in terms of gigapascal. Even if you write the unit as kilonewton per millimeter square, it's okay, it's acceptable. This will be giving a plus point only. Okay. Here is one more question. A hollow steel tube of 3.5 meter long has an external diameter of 120 mm, and in order to determine the internal diameter. You have to calculate the internal diameter. Tube was subjected to tensile load is given to 400 kilonewton. The extension delta L is 2 mm. The modulus of elasticity is 200 gigapascal. So we have to calculate the internal diameter. Again, we are using the same equation, delta L is equal to PL by AE. So delta L is equal to PL by AE. We will be using the same equation. Delta L is given as here. This is given as 2 mm. So delta L is substituted. Load is given as 400 kilonewton. So 400 10 raised to 3. L, length of the specimen is given as 3.5 meter long. Okay, 3.5 10 raised to 3. We will be converting it into millimeter. And area of cross section we can calculate from the pi by 4 into d outer square minus d inner square. Where d inner diameter is not given. So we will be writing in terms of d as the equation for area. And after that, we will be multiplying with the modulus of elasticity. Okay, here one more bracket is here. We will be multiplying with modulus of elasticity. So only unknown is the value of d. We can calculate the value of d as 99.71 millimeter. Okay. So again, one more question. Two wire, one of steel and the other of copper, are of same length and subject to same tension if the diameter of the copper wire is 2 mm. Copper wire diameter is given. Find the diameter of the steel wire. We have to calculate. If they have elongated by same amount, elongated by same amount. That means delta L is equal to same. Delta L for copper equal to delta L for steel. These two wires the same length are subject to same tension. They have given the same tension. Load is same. Take E for steel as 200 gigapascal, that for copper as 100 gigapascal. So we have to calculate determine the diameter of the copper wire. Again, delta L is equal to PL by AE. So P1 L1 divided by A1 E1 is equal to P2 L2 divided by A2 E2. So from that we can calculate the diameter of the steel wire. So you can take this also as a homework. Here is our new topic, deformation of a body due to self-weight. Even no force is acting on the body will elongate due to its own weight. So we have to calculate the elongation of the body due to its own weight. For that we will be using the weight equation. Weight can be written as area of cross section into height into density of the material. So we will be writing in terms of WA into X. So we cannot directly use this in this equation. For that we will be considering a small section and we will be integrating from 0 to L. For the full length we will be calculating the material. So we will write the equation delta L is equal to PL by AE, and instead of P we will be substituting specific gravity W. So not specific gravity, density into area of cross section into dx. We will be considering a small distance. So W into X into dx. Okay. Instead of L, we will be considering a small distance. Load is equal remains the same. Okay. So the remaining W divided by E is taken outside, and we will be integrating the X dx. So we got X square by 2. So applying the limit, we will be integrating from 0 to total length of the bar. So 0 to L. We will be applying the limit. We will get W by into L square by 2. So we got the equation as delta L is equal to W L square divided by 2E. Okay. So we will be substituting the value WL by 2AE. So we got the answer. The capital W is the total weight of the specimen, which is given by W specific density into area of cross section into L. Okay. Here is our first question in connection with the elongation of bar due to its own weight. A copper alloy wire of 1.5 mm diameter. A copper alloy wire of 1.5 mm diameter, 30 meters long. So its diameter is given and its length is given, hanging freely from a tower. What will be its elongation due to its self weight? So we will be using L divided by 2A. So take specific weight of copper as and 89.2 kilonewton per meter cube, and modulus of elasticity E is given as 90 gigapascal. So here the given data, so diameter of the wire is given, length is given. So from the diameter we can calculate the value of area of cross section, and by using the weight length we can calculate its volume, and by multiplying with the specific weight, the density. specific weight, we can calculate the weight of the copper wire. So we can calculate the value of elongation due to itself, weight divided by WL square by 2E, where W is the specific weight, WL square by 2E. So we can calculate the specific elongation as 0.45 mm. L is given 30, A2. We can use the both equation WL square by 2E and WL divided by 2AE. In both equations, W is not the same. First one, W is the specific weight. The second one is the total weight, which is given by specific weight into area cross section into L. Okay. The next one, an alloy wire of 2 mm square cross section area. They have given the cross section area directly, and a 12 Newton weight. Weight is directly given. Hang freely under its on weight. Find the maximum length of the wire if the expansion should not exceed 0.6 mm. In this question, the value of delta L is given as 0.6 mm, and the area of cross section is given, weight is given, so we have to calculate the value of length of the wire. Okay. So here we will be using the equation WL divided by 2AE. So W, which can be calculated or already given. In this question, they have given the value of weight of the total wire. It's given by W, small w into area of cross section into length of the wire, which is given by 12 into length divided by 2AE. So A is the area of cross section and E is given. So we can calculate the value of L directly from the equation. So based on the situation, you have to use both equation WL divided by 2AE and WL square by 2E. Okay. Now we go to our new topic, principle of superposition. Actually, normally a body will be subjected to more than one force. So we have to analyze the force acting on it. And if the body is having different area of cross section, it will be difficult to analyze the whole force in a single stretch. So we will be cutting the body into small pieces, and we will be analyzing the total force acting on the body. So that is called the method of superposition. Sometimes a body is subject to number of forces acting on its outer edge, as well as sometimes sections along the body. In such case, forces are split up and their effects are considered individual section. So we'll be dividing the beam into, suppose here is a beam, and we got one force here, and we'll at a distance one force here, and at a distance one force here, and we'll got another force here. So we will be analyzing, if we are analyzing these forces, we will be considering this section alone, this section alone, and this section alone. We will be gathering the effect of all three sections at the last. The resulting deformation of the body equal to the algebraic sum. Sometimes it will, this body will elongate, and this section will compress, and this section may elongate or compress. Anyway, the algebraic sum of the deformation of the individual section will give the total deformation. Such a principle of finding the resultant of deformation is called a principle of superposition. So principle of superposition means we will be dividing the total beam into sections, and we will be finding out the deformation by individual section, and at last we will be taking the algebraic sum of the individual deformation to get the total deformation. That is called the principle of superposition. So you will get a good idea if you do one or two examples in connection with this. So here is our first question. A bar having a cross section area. They have given the cross section area 50 mm square. Subjected to axial force as shown in figure. They have given the forces. Determine the total elongation of the bar. Given E is equal to 2 into 10 raised to 5 Newton per mm square. So first thing, if you got such kind of question, first thing we have to do that whether the forces are in equilibrium. First thing, towards left force should be equal to the sum of leftward force equal to sum of rightward force. So in this, 80 kN towards left, 20 kN towards left, 10 kN towards left. The total equal to 80 plus 20 plus 10, 110 kN. And towards right, again 110 kN. So total force is in equilibrium. So our first step is over. The second step, we will be analyzing the section step by one by one. We will be analyzing the first section. First section I have taken this. I have drawn lines here for analysis. Okay. First section, I got a 80 Newton here. Okay, we will start from 80 Newton. If a body should be in equilibrium, it should have same force in two directions. So if 80 Newton is acting in the leftward side, there should be always 80 Newton in the right hand side. But in this figure, they don't have an 80 Newton in the right hand side. They got a 110 Newton. So we are introducing an extra 80 Newton in this right hand side. Okay. So we cannot simply add a force to the system. At the same time, we have to cancel that force. So this is also 80 and this is also 80. So among this 80 kilonewton is used here. So this is over. So remaining will be 80 kilonewton towards left is remaining at this section. Already there is a 110 kilonewton towards right is at this section. So net effect will be 80 towards left and 110 towards right. Remaining will be 30 kilonewton towards right will be the net effect. So I will be explaining once again. So I will be taking the first section. I am starting from left side. I will write the 80 kilonewton force here. If a body is subjected to 80 kilonewton force in the leftward direction, it should be, if it to be in equilibrium, 80 kilonewton force towards right should be there. So we will be introducing a 80 kilonewton force here. So for the I have drawn the line in equilibrium section. I have introduced 80 kilonewton force here. So we cannot simply add force to a system already in equilibrium, or the system is already in equilibrium. We cannot simply add a force to a equilibrium system. So I will be cancelling the force added to the system. The 80 kilonewton force is taken from here and it is displayed here. Now the system is having a 80 kilonewton towards left. So when I am analyzing this section B, it got a 80 kilonewton towards left and 110 kilonewton towards right. In net effect, it got a 30 kilonewton towards right force. Okay. So for the section BC, in the left hand side 30 kilonewton, for replacing that a 30 kilonewton towards the right hand, towards left direction I have to apply. So again, in this figure we don't have any 30 kilonewton force in this direction. So I will be introducing a 30 kilonewton force in this direction. Similarly, in the opposite direction, to cancel that force, I will be introducing a 30 kilonewton force. Among this 30 kilonewton force is used here. Here we have replaced. So remaining 30 kilonewton force is here. So at this section now, 30 kilonewton force is acting towards right direction and 20 kilonewton force is acting towards left direction. So net we got a 10 kilonewton force towards right direction. So in the third section, I will be writing 10 kilonewton force towards right direction. And at the end, if 10 kilonewton force is towards right direction acting at one end, in the other end, we should have another 10 kilonewton. At the end, we have checked whether it is matching with the end force 10 kilonewton. Now it is matching. So our force system equilibrium is satisfied. So this is the analyzing dividing section and finding the individual forces on the section. Okay. The next thing we have to calculate the total elongation. So we will be using the equation PL by AE. So we will be analyzing the section one by one. For the first section, PL divided by AE, PD is equal to 80 kilonewton, length is equal to 600 mm. Area of cross section they have given 50 millimeter square, and E is given as 200/5. So we got the elongation of the first section is equal to 80 into 50 and 200/5 into length of suspense equal to 4.8. For the next section, BC, again PL by AE. This is a tensile load. So we will be taking it as a positive. The second one is a compressive load. So we will be taking it as a negative. So again PL by AE. So 30 into length. It's a 1 meter long specimen. So L equal to 1 meter. And A is area cross section 50, E is 200/5. So you got a elongation of 3 m. Actually, we will take in this as positive and this as a negative. In the third section, CD, again we got a load of 10 kilonewton, length of 1.2 meter. So we will be substituting the value. Load 10 kilonewton, length 1.2 meter into millimeter, 1200. And A is equal to 50, E is equal to 200/5. Net effect again is a compressive, will be negative value. So we will be taking 4.2 as 4.8 as positive and 0.3 and 1.2 as negative. So net effect we will have a 0.6 millimeter is the total elongation of the bar. Okay. So we'll do one more question, so we get a very good idea about this. So in this question, the bar is having a varying cross section. So we will be applying the same principle of superposition by dividing this beam into n section. So I will draw lines at the sections for force analysis. Okay, we'll start from the first section. So here is the first section. For first section, I have 40 kilonewton here. So to cancel, to be in equilibrium, so I forgot one step. First thing we have to check whether the leftward force equal to rightward force. Okay. So towards left I got 40 kilonewton, 180 kilonewton towards left. Total 120 is the towards left force, and towards right 160 and 60. So total 220 is the towards right. So towards left force and towards right force are in equilibrium. Leftward force and rightward force are in equilibrium. So the system is in equilibrium. So our first condition, okay. The second thing, we'll be analyzing the section one by one. So we'll take the section. Okay, sorry for the inconvenience. Okay, so we'll continue. So here is our first section. For the first section, we got a 40 kilonewton acting in the left side. So obviously it will got a 40 kilonewton towards the right side. So in this figure, we don't have any 40 kilonewton force towards the right side. So we'll be adding a 40 kilonewton force in the towards the right side. Okay. So and we cannot simply add. We will be adding a additional 40 kilonewton force towards the left side also. So, and this 40 kilonewton will be used here, so it is got to cancel. Remaining will be only 40 kilonewton towards the left side. So analyze it. When we are analyzing section 2, we got 40 kilonewton towards left and 160 kilonewton towards the right. So in net effect will be 120 kilonewton towards the right is the force on the section. So we'll be adding a 120 kilonewton force on the right. If 120 kilonewton acting in the left side, obviously it will have a 120 kilonewton in the right side also. Again, we checked here, we don't have any 120 kilonewton force. So we have added a 120 kilonewton force towards the left direction. So we will be adding another 120 to cancel the force we have added. And already a first added 120 got cancelled because we have already used it here. So remaining will be 120 Newton towards the right direction. So we are analyzing this section, we got a 180 kilonewton towards left, 120 kilonewton towards right. Now net effect will be 120 minus 180, it will be 60 kilonewton towards the left is the force acting on this direction. If it is 60 kilonewton on the left side, obviously it got 60 kilonewton towards the right. Check whether it have the 60 kilonewton at the end. So we got a 60 kilonewton at the end. So our section is in equilibrium. Our solution is correct. So next thing we have to calculate the total elongation of the bar. They have given area of cross section A1, A2 and A3. E remains the same. It is 1.9 × 5 Newton per millimeter square. So we will be calculating the value of delta L using the equation PL by AE. So P is equal to, for first section it is 40 kilonewton and area of cross section 30 millimeter square. For second section, P is equal to 120 kilonewton and area of cross section is equal to 40 millimeter square. Length is equal to 50 mm. For the first section it is 60 mm and third section it is 40 mm. Okay, so we will be calculating the value of PL by AE. For the first thing, we will be calculating P is 40 kilonewton, length 60 mm, area of cross section 30, E is equal to 1.9 × 10⁵. So we got, for first section we got a tensile load, it's a positive. Second section, compressive load, it got a negative value. Third section, tensile value, it's a positive value. So it's a positive value. And for second section, we'll be applying the load P2, 120 kilonewton, length 50 mm, area cross section 40 and E is equal to 1.9, it's a negative value due to compressive load. For the third section, we got a P is equal to 60 and the area length is equal to 40, area cross section 50 and the E is equal to 1.9 × 5. We got a delta L is equal to 0.253 as it is a tensile, again it's a positive value. So in net effect, positive, negative and positive, 0.015 negative is the total. In total, the whole system get compressed by 0.115 mm. So that's all for today's class. We'll be discussing more problems in the coming class. Thank you.